If your EdenPURE has ever given you this alarm, you're not alone. I'm checking on YouTube. I see lots of people have had the same problem. They say the EdenPURE is aware of the problem, and the solution is to purchase a circuit board costing $50. Well, for $50, using parts you can get at your hardware store or on Amazon, I can get your EdenPURE running again. I can't save the ultraviolet light that makes the ozone. That's not going to be savable. That needs the circuit boards. And we'll be disconnecting those circuit boards. So let's start, and I'll show you how we do this. First, we have to take off the back cover of the unit. There's 4 screws that do that, and this is what it will look like when it's off. And this is what the circuit board looks like when you take off the back cover. In normal household wiring, black is hot and white is neutral. But you can see here we have connectors where both wires are white or both wires are black. I went through there and marked the white wires that were hot red and the black wires that were neutral white. Now, checking out that back circuit board, I see there's 4 diodes, little black boxes. And to the right of that is a silver can, which is a capacitor. Normally you would think that those 4 diodes are a full-wave rectifier, but let's check. If I put the probe to the positive terminal of the can, it tells me it's a half-wave rectifier. Okay, let's check out the ultraviolet light bulb that gives you the ozone. When you turn on the unit, the ultraviolet light bulb turns on briefly and then shuts off. Checking out the light bulb better, I hooked it up to the oscilloscope to see what kind of voltage that light bulb runs on. It runs on 2¼ volts AC. The UV light bulb is connected to line voltage, but there's also 2 smaller wires coming from the circuit board, which I assume turns the bulb on and off. So let's check that out a little bit. So I put the scope probe to the red wire to see what's turning on and off the ultraviolet bulb. As you can see, when the bulb first turns on, it gives you something like a sine wave. That sine wave is 84 volts AC. That only lasts a little bit, then the voltage drops down to 82 volts AC when the bulb turns off. This is why the ultraviolet light bulb won't be savable. It's connected to the back circuit board, and I have to disconnect both circuit boards to get around the unlevel alarm. Now we can disassemble the unit further and start the repairs. You need 3 parts for the repairs. As you can see, you can get them on Amazon. We need a common thermostat that you can get at any hardware store, and we need a furnace temperature switch and also a normally open momentary push button switch. For the push button switch, get a good quality switch because this is part of the safety features and we don't want to scrimp on safety. To get the faceplate off the front panel, the tabs are 1¾ inch in from each side of the faceplate, yet the skinniest piece of steel you have to reach in there and pry out the top of the faceplate. And here's the front circuit board. Just disconnect the ribbon cable from the board and put the whole faceplate to the side for a while. Now to get the whole front cover off, 2 red arrows point to the screws you need to remove. There's 3 more screws on the bottom of the unit that have to come out. Now putting the unit on its back, there's 2 square tabs that have to be pushed in and pry up that end of the front cover and then slide everything off to the top. Now this is what you should be looking at. To install the furnace temperature switch at the top of the heat chamber, I just took a quarter and drew a circle, and then got a drill and drilled holes all the way around that circle to remove that metal. Then you install the furnace temperature switch. This switch is going to be used to turn on and off the blower fan. It runs independently of the thermostat. And to get a seal on that switch, I used a high temperature thermal paste. You could probably use automotive gasket material, because that chamber doesn't get any hotter than 200 degrees. Here you can see the temperature switch poking into the heat chamber. The momentary push button switch is mounted to the bottom center of the heater. When the heater is upright, that momentary switch pushes in and closes the circuit. But when it tips over, the momentary switch extends and it breaks the circuit, shutting off the heating elements but not the fan. This is how you wire that switch in. 1 wire comes down from the thermostat. The other wire comes down from the furnace temperature switch, joins with the line neutral wire, and connects to the other terminal of the push button switch. Now it's time to install the thermostat to the top of the unit. It doesn't matter which type of normal thermostat you get, just make sure that when you mount it, everything clears the heat chamber. You have about 1.5 inches of room to do that. On the back circuit board, they have spade connector terminals. The ones that have an N tacked on to the designation are for neutral. The other ones are for hot, 120 volts. Now here's where I changed things. All the neutrals were connected together, but all the hots were not. So I decided to use all the neutrals as hot, and it just simplifies the wiring and kind of ends up, believe it or not, looking a little cleaner. You can see where I have my hot wires marked red, and they each go to a terminal that's marked N. This retro upgrade will be switching the neutrals on and off, but the unit has power all the time that it's plugged into the wall. That's why I had to tape off the 2 N terminals to the left of the blue connectors, so that in the future nobody would be surprised. Safety first. This is what the final wiring looks like. The ribbon wire coming from the front circuit board gets disconnected from the back circuit board. There are 3 heating elements. I disconnect one because when I had all 3 of them connected, the plug got a little hot at the outlet. Now the big tag on the power cord warns you of this, but I didn't want to risk anything. I was just going to fix this unit and give it back to its owner. So to play safe, I just disconnected the 3rd heating element, and the unit runs on 2 elements only, puts out plenty of heat, and the 3rd element can be used as a spare. As for the fan, one side of it is always hooked into 120 volts. The other wire, which would be the neutral wire of the fan, goes up to the furnace temperature switch, as I showed you before. The 2 heating elements on the right side with black wires are always connected to line voltage. The neutral wires, which are the black wires marked with white, go up to the thermostat. The other side of the thermostat goes down to the tilt switch. Now it's time for a test. When I reach up and turn off the thermostat, you can see the heating elements cool off, but the fan will keep running. It will shut down when the chamber gets below 90 degrees. That will happen also if the unit ever gets tipped over. If your unit ever tips over, you just have to stand it upright again and everything works just fine. Now all you have to do is button up the unit, put the back cover back on, and it's good to go. I hope this video helps you rescue your EdenPURE. I'm sure the thermostat, furnace switch, and tilt switch will be much more reliable than the circuit boards they put in these units. Good luck, guys.